The Rebel Hot continues in video number 2 in the build series. We're going to get all of the wings done in this episode, maybe some of the other details. So stay tuned and we'll dive back in to the Rebel Hot from Carf models. So we've got our wings laid out here on the table. First thing we're going to do is I'm going to deal with all the landing gear. So the landing gear, the mains, and also the nose. So I'm going to pull those out as well too. We've got a bunch of Loctiting to get done on those guys. When I was prepping this for the rudder, I put a little bit of sideways force on there and broke it. So I took one from the wing package and used that on the rudder. So we have to make another one of these guys. Basically all we're going to do is take a piece of ply that's the same thickness. We're just going to trace this out from the good one on here, and we're going to cut this out of this ply and make another one of those guys. So we need to do that as well too. But we'll pull all the landing gear out and get that stuff sorted. All right, so we got all of our gear out here and we've Loctited everything. So basically on the JP gear, you've got the bolts holding the retracts together, and then the actual landing gear itself, you have the bolts holding the wheels together. The bottom ones on the JP retracts, always suggest checking these out, but these are all generally always Loctited. I've never had a set that bolt is not Loctited, so in this case this one is as well. The fronts, same kind of setup here, side of the retracts, wheel, but the only kicker with the front is you got to take the leg off and you got to get these two fasteners that are holding the servo plate onto the trunnion. That's an important step because those guys will come loose very quickly, and the nose goes back together very simply. There's a generic groove all the way around that pin. So it's pretty easy to go back together. All right, so we've got our servos mounted to our plates, our aileron plates here, exactly the same system used on the rudder. And the openings here, we also have to do the same thing. So there's a wood piece set back about 5 millimeters from this current perimeter. So you just take a Dremel and you just go around, and that'll give enough room for these servos to go in, because right now there's not enough room for the servo to actually pass by here. So you do have to sand those. Landing gear wise, the landing gear should fit in there no problem. The width of the rails here is good, fits in between the rails, but again our orange piece here needs to be trimmed out a little bit. So I'm just going to do just the back section right here. Now it looks like initially this won't fit in the front portion, but the actual gear cutaway sits about back here. So as soon as that's in the right position, this leg should fit in there no problem. So don't be, if you're building one of these, don't start sanding this until you actually get the gear installed first. All right, so I got the one gear fit on the left wing here. Definitely have to do some sanding in this area. Got to open up this former to allow the gear to sit in this pocket. So not a big deal, just some Dremel work. So what I'm doing now is we've got our gear installed, and I'm just getting this centered. I do have my manual controller here, my Electron manual controller hooked up. This allows us to basically extend the gear, retract the gear in the wing pocket or in the wing or whatever, but this allows us to get it set up. So I'm basically getting this set up. I'll get one screw installed, ensure it operates and it's centered and everything, we're happy with it, and then we'll install the other 3 screws. Now I'm not going to do this gear install permanently right now, meaning I'm not going to put some CA in the holes because we're going to take the gear back out in order to get our flap servo installed, but I want to get the gear 100% sorted before we move on to our surfaces. All right, so our left gear is installed here. To install these we use some number 4 by 1/2 inch wood screws. These have the Robertson heads. For you Americans, that's a square head. The nice thing about the Robertson heads is they're pretty much impossible to strip out. So anyways, this is ready to go. I'll just show you guys what it looks like here. So the key is getting this kind of nice and centered, but you're always hugging the furthest away from the opening, because as this thing comes up or out, it moves towards this portion there. So it's going to look a little bit off center, not much, but it works beautifully. You can see there now we're pretty much centered all the way around. There we go. Beautiful. Now we'll accomplish the same thing on the other wing. All right, so both of our gear are done. We're gonna pull these gear back out. Not gonna worry about checking the toe-in right now. We'll check that later on when we go to reinstall the gear. So we're gonna pull this gear back out, and then we're gonna start to work on our surfaces. So we'll run our ailerons first, get those wires run to the root here, and then we'll also work on our flap servos. Sorry, our flap servos go there. So we know our wires are gonna come out in this portion, pretty common for all the Rebels. So this is where our main connector is gonna be, our Ashlock connector. And what that means is that is going to go into the fuselage right in this location right there. Now thinking about the Ashlock connector, pretty straightforward. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we use a 12-pin Ashlock connector. 2 of the pins will be blank, but that will take care of all of our devices in one connector. So it'll be nice and simple. All right, so we did up our connectors here. So we've got 2 for our ailerons. Sorry, these are our flap ones. They are marked. And then we've got 2 for our ailerons over there. So we're gonna get those run. The path is pretty simple on these small wings. Everything's gonna come through this spot right here underneath the wing spar and out. All right, both aileron servos have been installed. The kit comes with multiple size screws, or 2 different size screws. So there's these small guys here, and then there's bigger screws right there. There's 2 side by side. So the bigger screws are your hatch screws here, and the smaller screws are your wheel cover screws. So you can kind of tell because the opening in those items is different. That's a small opening. The hatches have big openings. Just getting the flap servo set up next. This is always how I do it, and it's nice to get these set up, synchronized, working exactly the same, mechanically the same, locked out and everything out of the airplane. It's so much easier. So the way this flap sits in here, this is the right wing. Servo obviously sits right there, and our output shaft sits on this side, the back side, sorry, the leading edge of the wing, and the arm is going to go up, in this case towards the underside of the wing. So right now, this right servo arm is in full flap position. Reason for that is you always want your linkage to be mechanically locked at full flap. So when this goes to full flaps, your linkage is straight out, your flap is fully extended, and it's going to be going towards the flap itself. So that is full flaps on both of those servos. This is the only position that matters right now in the radio. The other positions, I just set up random numbers that are a little bit of movement. That's takeoff flaps, that's flaps off. These are going to be adjusted with our adjustment in the radio, but this is mechanically locked. So that's the most important one to set up initially. So the way we do our flaps here is we use our butterfly flap menu. Let me go back to something more basic here. So we're going to go to our model, function assignment. So flaps right now is our flight mode switch, which is SD. Okay, so this is our flap switch, but it's really our flight mode switch because we have flight modes set up. So then we have our servos obviously allocated to channels 7 and 8 for flaps. So flap 1 is 7, flap 1 is always left. We're always working left to right. So flap 1 is 7, flap 2 is 8, which is our right wing. So then we go into fine tuning, we go into our butterfly flap menu. We use the log max as our control. This is your flight modes. When you set this up, you can pick different controls. You could pick the SD switch, but we use the log max. And then from there, what I do at this stage is I always go to full flaps and get this almost maxed out. So what I'll do is, if I go to this servo as an example, right now we're at minus 100. If I continue to move this, I can get more travel, like 130, but I always want to leave a little bit for us to be able to find our mechanical lock. So I went to 130 on the servo, dropped this down to minus 100, and in that case we should be really close to the mechanical lock, but we do have some adjustments there. So when we switch to our other flight modes, so now we're in takeoff flaps, we're still at -100, but the servo is going to still move a little bit. And then landing flaps, we're at -121, and the servo's moved a little bit again here as well. So now these servos are ready to install in the wings. So what we want to do is we want to get our linkage installed on the servo side, and hopefully we can tuck this through. We don't want to have the ball or the clevis on the outside because we are going to have to adjust this. So this may take a bit of adjustment in and out, but this is ultimately how this step is best accomplished. All right, so we've got our flap servo installed here. You can see our two clevises are basically butt up against each other, and that actually gives us a great amount of travel on this flap. It's about 48 degrees, I think, is what it ends up being. And that number also comes from the Rebel Classics that I've built as well. So I put mine together here. I'm doing some gear maintenance on it, but that flap is about 45, 48 degrees when it's all set up. So there's the gauge right there. So pretty straightforward setup here with that clevis being butted up with each other. So I'm just going to get the flap servo screwed in place. We're using our small servo screws for this, and those are perfect. All right, so we got our gear installed, our flaps all done, and I'll just show you the path here for our brakes. So these gear are a little bit different layout than the ones that you find on a Rebel Classic, but basically we brought our brake line through the back of our linkage. It needs to come across the actual plunger there, and it needs to come out the back side of the landing gear or the direction towards the tip of the wing. This gear is almost touching the motor, so you have no room to put anything down in this area. So it's very important to have the brake line run out this area. So when we do that, we wrap it in spiral wrap like that. And a couple of the key points here is the spiral wrap comes to this point right there. Put another layer of electrical tape or black tape around it here. And what that black tape does is when you put the cover on, it forces the line to go in to the opening there. So I'll show you guys here what it looks like. Just like that. So that is definitely the best way to install that landing gear. It works perfectly. So what we're going to do now is we've got this all set up. A couple important things too is I rounded this off a little bit so it doesn't catch our landing gear line. What else here? Put a little bit of CA on our screws when we screwed them in, and we're going to check our alignment now is the next thing we want to do. And then if we're happy with the alignment, we're just going to make sure we snug down our trunnion bolt right there, which is a Torx bolt. So I know on the Rebels, the root of the wing is parallel to the flight line, so we're going to carry this over, run a tape line, and just confirm that our wheel has a degree or two of toe in. All right, I did round off the portion of the cover that is towards the landing gear tip there. You can see the difference. So just rounded that off a little bit to make sure that we have enough clearance for our brake line to pass through there. All right, so what I do now is I get my measurement from the first wing that I've completed, and I set up my linkage on the second wing here, so I know that my full flaps is bang on perfect. You can see there we are perfect angle matching both of them. So that's awesome. The other settings, takeoff flaps, off flaps, we will do those individually. All right wing is complete. Now all of our gear and aileron servos are done on both of our wings. So it's time to do our wiring. So as mentioned previously, I'm going to use a 12-pin Ashlock connector. We're going to put a nice piece of snakeskin on there. We're going to have the wires sticking out of the wing about this much. It's nice when you have that availability to just tuck them inside, because then connecting them together makes it really easy. So we're going to leave the wires about that long. So I'm going to get my Ashlock connectors out, my pins and all that stuff, and we're going to get this moving along. So we've got both of our wire leads coming from the wings complete. Those are all done. Now this is a great opportunity to set up our aileron servos. So our left wing, which is aileron 1, we've got that plugged into port number 1 on our Rex 12 receiver. That's powered up and our radio's on as well too. So first thing we can check is to make sure that our direction is proper. So when I give this left aileron, our servo should move towards the surface and it's moving backwards. So we go into our model menu, servo setup, aileron 1, and we're going to reverse that and we'll check and we are good. Centering, we've already centered those guys, so that's done. So now all we need to do is we're going to get our clevis to clevis linkage set up, and with this nice and centered while we're powered up, we can get that surface perfectly centered and adjusted. Okay, so ailerons are all set up. Put a little bit of shrink tube over top of the linkage and those worked out awesome. No problems with that. We've got our flaps plugged in now, and this is what I was talking about with our flaps. So if I go to flaps off, you can see there that we still have lots of adjustment to do there. The most important thing was our mechanical lock on our flaps, which is what's happening right there. So now the force on the flap itself, the motor isn't actually holding that force. It's all transferred right through the shaft. So both of those guys are set up. So we're going to take our angle finder, and we should be bang on equal here, but we'll just confirm. So that side's good. And that side is good. So perfect. So what I'll do is I'm going to adjust the other ones just simply to have a flap off setting, but we'll do those adjustments when they are on the aircraft. So I like to do those other adjustments while the takeoff adjustment visually. We can also use our angle finder as well too. So we'll do that for now. And one of our final steps will be visually setting those guys up. All right, so we basically have our flaps set up here. So there's off, takeoff flaps, and landing flaps. All right, so next thing I'm doing here is getting our nose set up. So we've got our leg already done. We've already Loctited all that stuff. And we've got our servo installed. So servo, this fit best mounting in this format here. You can kind of see how we've got it all laid out. And I did the cross pattern with the servo linkage to number 1, save space, because it makes everything more narrow is really the primary reason. And this linkage kind of worked out better for this setup. It wasn't long enough to come straight in this output shaft location, so the cross pattern kind of made the most sense. And there's the operation there. I've got it, it's probably a little bit too much travel, but that works. Now, a little point of interest here, you may be wondering if you're watching this series, why I used an aluminum arm on the steering. Well, in all the other areas, clevis to clevis, clevises work great on all types of servo arms, but the nylon arms are really designed for clevises. Putting a ball joint on a nylon arm is not a good idea because it adds sideways force. So we wouldn't want to use the nylon arm on this setup because you've got a ball joint on the servo side. So the aluminum arm just made the most sense. All right, so a couple points of interest here. Did just a little bit of sanding on that former there to allow the tank to drop in place. Previously, this holder for the tank was sitting up like this. So that fits beautifully now. And this 3D printed tank holder is going to work awesome and just screw right into the engine rails. That's a really wicked design. I like that a lot. Anyways, the point of me showing this is the wing bolts are like every other Rebel where they're done from inside the fuselage. That's where they're supposed to be done. Well, you lose all access to those wing bolts on this aircraft. So we're going to flip this around and reverse the wing bolts. So the procedure when you're putting this plane together is a lot like bigger aircraft where you would put the plane together, drop the landing gear, and then tighten these bolts up from inside the wing itself. So what that entails is there's a blind nut buried in here. So we're going to drill that blind nut out to allow our bolt just to pass through there. And we're going to get a blind nut installed on the fuselage side so this can thread in. Right now it's just an open hole. So that's how we're going to make that work. And that'll be one of those things that we can do at the end of the night where we can just put the wings on. install these guys, screw them down so everything's lined up nicely and it can cure overnight. So we're going to save that for a little bit later. Tank install here required the engine to come out. That's why the engine is out. And I just wanted to get that tank in there to see about access for bolts and all that. So next thing we're going to do here is we are going to get our wiring done for our wing side. So we do have a big cavern in this area. We're probably just going to go somewhere in the middle just to keep it nice and simple. But we're going to have the other side of the Ashlock connector coming out of the fuse right there. All right, so we got both of our fuselage side extensions done up here. Now these wire lengths, I just did 8 pieces of wire exactly the same length. We took our white wire out of our gear and our brake line, and those run to the same length as the other ones that we ran from the tail. So basically up to this kind of area right here. We're going to shorten those and put ends on them once we get our plate figured out for all of the equipment. So because we're not putting our servo ends on this side yet, we're going to mark these guys out. So we're going to put some shrink tube over top of this portion for about maybe 6 inches, and I'm going to mark each one of these guys out. Obviously they relate to the wing side plug layout, which is the same for both wings. All right, getting ready to install our blind nuts on the fuselage side here. So we're going to install the blind nuts just like you would typically install them, and they are going to go in like this, and the little claws are going to dig into the wood backer. So what we need to do is we need to drill these guys out a little bit. So these are 4mm blind nuts to go with the wing bolts that come with the kit. And to drill out the blind nut for that, you want to use a 3/16 drill bit, which we have loaded up here. So we're going to drill those guys out and get these guys sunk in place. Once they're sunk in place, we'll mix up some high sol and get those things fastened down. And then we'll have to drill out the blind nut on our wing side, which really isn't that big of a deal. You just got to drill it out big enough so the bolt moves freely in there. All right, so we got the plane flipped over and just bolting the wings on in reverse of what they normally would. And this actually is super easy with one of these Dubro ball end drivers. You can get in there no problem. So I thought this was going to be difficult, but it's actually very simple. So good change on this wing for that better fuel tank setup. So we're going to flip the plane over and get some high sol installed on the back of those blind nuts. But I think what we're going to do first, while we've got the plane flipped over, is we're probably going to get our front gear mounted in place. So that's probably a good time to get this done. So we'll get the gear installed and see how that's going to work out. All right, front landing gear is installed. Very simple. We use the same screws that we used in the main wings. So those are number 4 Robertson heads. And we also put a landing light from Sky Candy on the nose. So we're going to do an install of a Sky Candy landing light just on the nose, just to keep it simple and not a huge power draw or anything like that. So we've got the landing light here. The electronics for the landing light are here. So this just gets power through the lead right there. And then what we'll do is we will add a voltage regulator, which is a Castle Creations. So a Castle Creations 10 amp BEC right there. And then we will also add an SPO6 switch from Jetty. And what that's going to do is that's going to hook right up to the battery. That'll give us control of the lighting system from the receiver and also be able to turn the power on and off for the lighting system. So that's the plan for the front nose light. All right, so I think we need to start getting all of our glued details completed here. So what I mean by glued details is like our pitot tube in our nose, our hatch latch, our tray system in the main fuselage section. So all of that stuff needs to get sorted out because it can't really progress forward until that stuff is taken care of. Right, so this is the thought process time. This plane's actually probably proving to be a little bit more complicated than the other Rebels because it's not kind of normal. So because we're not using the stock tank, we've got this nice big area right there. So what we're going to do is I think that's where we're going to put all of our equipment stuff. So it's still going to be nice and very well hidden. And just brainstorming here, but I'm thinking about doing a carbon panel in this area, just tucked underneath. More of just a cover plate. I think that's going to look cool, so I'll probably do that. Maybe putting our connections for like the gear controller and all that stuff in those plates. So just giving this some thought about how to lay things out, but I'm pretty sure that's exactly where we are going to put our main gear plate. So just using the cardboard as a template, probably gluing in 2 cross members, and that is a nice fairly flat area as well too. If you think about this in relation to the gear plates, you're kind of looking for the same level as the gear plate. So when we get to the point where we want to glue that in, we can take our electronic level, put it on here, and confirm that we are matching on our equipment plates. So I'm going to give that a little bit more thought here, and probably cut this kind of shape out of a single piece of cardboard and see how that fits. All right, so we got our plate all worked out here. So we've got our carbon plate or fake carbon plate laminated to some plywood. There's a cross piece on the front. The back has a single 3/4 inch piece of plywood, a plywood block, a 1 inch by 1 inch block. And this layout here is perfectly level to the front gear mount. So that is exactly what we're looking for. So now what I want to do with all these things is I want to mark these out. Just take some pencil or Sharpie or whatever, mark those out, and basically I need to sand the fuselage in our gluing areas. It's very important. The fuselages are generally quite slippery, so you want to sand that out to make sure you get good glue adhesion. So here's the things that we're gluing. We're gluing that tray in. We've also got our UAT mount, which is this guy here, and that is going to get glued right there, right behind the wheel thing there, so right behind the cover. So that's where that's going, so that needs to get sanded out for gluing. And we don't really have anything in the front end yet. I'm not sure if our batteries are going to go here, here, right in the nose. So we got to wait on those things, but those are our 2 primary main things that we're gluing at this time. So we have our main plate there glued in place. We've got our UAT holder, which obviously is hidden underneath the big ball, and also did up my connection for the steering servo and got that guy plugged in. So we've done a nice spiral on there, so that'll keep itself out of the way. And then this line is going to be run right underneath the ridge there and run all the way back. So there's lots of line there to go underneath the tray. So ultimately, very happy with this layout. I think it's going to work good. It's going to be nice and clean, and it's a good compromise for the hidden setup. All right, it's the next day, and our pieces that we glued in are nice and solid. So what we can do now is we'll take a look at how things are going to come through the board. So I think I'm still going to hide all of our wires underneath the board just to make it nice and clean. And we're going to put a through fitting on the board, so probably somewhere in the center here. So it's time to pull that board out and kind of think about getting our equipment laid out. All of our wires are pulled back here, and of course we've got a ton of excess wires, so we'll be able to figure that out and put ends on there, no problem at all. So let's yank that board out and see what we can do for organization. Coming up with the basic layout here, we've got our Cortex. I've already glued that down with the double-sided tape. Gear controller, I think we're going to put right there. We've put a through fitting through the board. These are available on our website. This is the 10 by 30, I think, something like that. This is a nice size because it's small, but you can still fit power wires through and stuff if you want to. And I think we're going to put our DSM-10, our power control, right there. We could also mount this underneath the board as well too, so that's an idea. And so if we do that, then we've got our R3, which is our on-off switch. That could mount on the board like this. And then we just have a lead going to the DSM-10, so the R3 will turn the DSM-10 on and off. Now we're also going to be adding a 900 receiver into the system. So this one here, we could add it a couple different ways. The first way we can add it is as a second receiver into the Cortex. So our primary receivers in B, we could add the 900 in A. We could also have the 900 plugging into one of the E ports. So as far as telemetry goes on this aircraft, we basically have the Zykoy telemetry from the turbine, And that is pretty much it. Nothing else needs telemetry. So that does leave an open port here, the E2 port or E1 port for our 900 receiver. So we'll see how that's going to work out. I like to put this in the primary receiver generally. So anyways, we'll figure that part out. But I think this is going to be our layout here. I like that. As far as power goes, we're going to have the primary power from our DSM-10. That powers our control system on the aircraft. Now on the downside, or the battery plug-in side of the DSM-10, we can split off here, and that is going to have another split coming to the gear. So that's going to be straight battery power, and this electron controller turns on and off. It doesn't receive a signal anymore. So that's the electron controller, and then these leads will all bunch together and we'll go to the front of the plane where we'll have one battery for the receiver and gear system, and then our second battery will come back and plug into our turbine control board. With Jetty, when an owner gets a plane like this, I send them the program. So they've got the program they put on their radio, but they still need to bind all of the things to the radio. So what they need access to is the EXT ports on all the devices. So we need access to the EXT port on the primary receiver, access to the EXT port on the 900, and access to the EXT port on the R3. So because this isn't like buried, hidden in the aircraft, I'm not going to do any extensions for any of this stuff because you can just reach in here and plug things in as you need it. So that's how we're going to lay this thing out. And I'm going to get all these items fastened to this board. All right, so we got our wire bundle all set up here. So just to clarify this, so our battery plugs into this lead at the front of the aircraft. That power comes back to the DSM-10, which is underneath the main board. This connection here comes right from the battery because this is all teed up together. That's going to come through the board, plug into our electron controller. This is turned on and off by the DSM-10, which comes through here and plugs into our Rex 12, which powers all of our radio equipment on the aircraft. The reason we don't put the gear through the DSM-10 is that would add to the amperage load on the DSM-10. It probably would have no problem handling it, but the Electron has a built-in on and off when it gets a signal, right? So there's no reason to have this go through the DSM-10 when you can have a battery going straight to it. So that is our power system. I left this long. I left it without a plug because I don't know where our batteries are going to go at this point. All right, guys, and that wraps up video number 2 in the build series of the Carf Composite ARF Rebel Hot build series for this amazing little RC jet. Very cool little plane. Excited to wrap this up in the next video. Video number 3, we'll wrap up this entire plane. We'll be doing our engine runs, programming, all that stuff. So nice, quick build series on this aircraft. It's going together very well. And next video, like I said, we're going to wrap it all up. So a couple plugs here for you. Don't forget to check out the Lighter Side of RC After Dark. Our After Dark channel, it's a completely separate channel. We do live streams here from the shop for about an hour to 2 hours every 2 weeks. During the summertime, it's a little bit different. Sometimes we'll do it from events, but it's a ton of fun. The coolest thing I like about the live streams is getting to interact with you guys when you're on the live streams while it's happening. So you get to ask us questions. We can see those questions. We can respond to them in real time. So tons of fun. And the second thing I'll mention is channel membership. Thank you to all you channel members out there. It's a paid service, and we've got quite a few channel members, which is super awesome. Benefits of channel membership is you get to get early access to the videos before anybody else. So often we'll have 1 to 2 weeks of videos, so 2 to 4 videos uploaded to YouTube, and our channel members get to see those videos before everybody else in YouTube world gets to see them. So a cool perk, I think, for sure, and we've got some great response from our channel members. So thanks guys so much for watching this video. As these videos are being released, we're headed down to Montana Jets, where the beautiful F-14 behind me will be maidened, along with a lot of the other aircraft we built during this past winter and fall season. So look forward to those videos. Thanks so much for watching and supporting the channel, and we'll see you in the next video.